Endless Year, A Story of a Wave by Curtis Upton. Here we see the death of a wave, the peeling slope that as surfers we revolve our life around. But how did we get to this stage? Let's look at the story of a wave, from creation all the way to its death at a beach. A wave is defined as a long body of water curling into an arced form and breaking on the shore. But what does this mean? It's common knowledge that the wind plays a big part in wave production and quality. So let's first look at the pressure systems which cause the winds. The initial source of energy is the sun. Air flows through the path of least resistance. This causes movement when a heat source is introduced. This is seen in a troposphere. As the ground heats up, this heats the air up above it, causing this air to rise. Once risen, this air then cools as it is further from the warm land. It then drops back down in areas of low pressure. This happens locally and on a mass scale. These are known as convection cells. Different parts of the Earth's crust are heated to different degrees because of their position in relation to the sun. On the equator, the Earth's crust receives more heat than at the poles. This causes warm air to rise, then flow towards higher latitudes where it then descends back towards the equator, thus causing a massive convection current. As well known, the Earth spins anti-clockwise. Because of this, we experience a force called Coriolis force. The Earth spinning deflects the wind. In the southern hemisphere, it goes to the left, and in the northern hemisphere to the right. Because of this, wind flow around high and low pressure systems circulates in the opposite direction in the different hemispheres. Just like liquids, gas also flows from high to low pressure following the path of least resistance. When wind passes over water, it causes friction. This offsets the glassy surface of the sea, depending how long it blows for, could create waves. The further the wind blows over the sea, the more friction is created and movement passed onto the water's surface. There are three factors with the wind that affects the size and power of waves: the intensity, known as velocity, length of time it blows, and fetch, the distance it blows over. If the wind only blows over a short time frame or distance, then chop will be created. This is small ripples on the surface of the sea. The retaining force is the surface tension of the water. Once the wind stops blowing, the chop will quickly settle back to flat water. This creates weak waves, not ideal for surfing. If the wind blows with higher velocity and a bigger fetch, it can create swell. This is lines of water passing on its energy by going up and down, hardly moving forward until the wave breaks into white water. Swell with increased period and wavelengths gives more power and generally a better wave. We are now into the last section of the wave story. Once the swell has been created and travelled towards shallow water, it will be able to fill the bottom. The orbitals will reach the seabed. However, as it travels towards land, the swell warps and wraps around the coastline. This causes refraction, diffraction, and reflection. Refraction is when the swell bends around a headland or part of the coastline that sticks out. Diffraction is when the swell is run through a smaller area, for example between mainland UK and Ireland. Reflection is when the swell hits an object head-on, consequently causes a backwash wave, washing back out in the direction that it came. Refraction and diffraction also affect tide time. This is because as the water rushes in or out, it has to travel around any land. It can't just continue its path. This causes different tide times at different places and can cause what look like irregular patterns. For example, the Witterings on the south coast partway through their tidal cycle. This is because the water is diffracted by the Isle of Wight. As the waves crash into the coast, they cause coastal erosion. Destructive waves erode the coastline and often cause steeper beaches in the winter and flatter ones in the summer. Depending on the force of the current and swell, larger pieces of sediment can be eroded or washed along the beach. Constructive waves do the opposite of this. They build the beach. This happens when the wave has more force washing in up the beach than coming back out. This has the ability to make new sandbars or add to existing ones. Finally, once the wave has been created, travelled towards land, and has possibly been ridden, it eventually breaks onto the shore. The energy from the wave is transferred into sound, vibrations, and heat. This is the end of the wave's story.